Hey, welcome back to Math with Patrick. Today's May 27th, and we are solving problem number 147 from the Daily Epsilon calendar. And we need to find the number of two-digit numbers larger than 20, whose digits sum to a number divisible by 3. Okay, let's do a little bit of vocab stuff. So let's find the number or amount of two-digit numbers larger than 20. So we're looking at numbers 20 through 99. Whose digits sum to a number divisible by 3. So I could sum the digits of, say, 20. 2 plus 0 is 2. I could sum the digits of 99. 9 plus 9 is 18. And then it's asking us to figure out how many of these two-digit numbers have sums of their digits that are divisible by 3. So this 2, unfortunately, is not divisible by 3, so that one won't work. And this 18 is, so that one does work. And now I just need to figure out how many numbers between 20 and 99 work for this problem. There is a fun trick here, though. This digits sum to a number divisible by 3 thing. This is a strategy that I like to use, and I have used in a lot of my videos, to test divisibility by 3. So, for example, the number 141, I know is immediately, I immediately know is divisible by 3 because its digits sum to a number that's also divisible by 3. I know that, 2 times 3 is 6. 6 divided by 3 is 2, right? 6 is definitely divisible by 3. I actually don't really know off the top of my head how, what my quotient would be if I do 141 divided by 3. I mean, I could figure it out pretty quickly right here. It looks like it's 47. But we can use this trick of relating the digits being divisible by 3 to the actual numbers being divisible by 3. So 20 didn't give me a number here divisible by 3 because it itself is not divisible by 3. We could try this out with the number 21, which is 3 times 7. And if we add the digits here, we get 3, and that number is divisible by 3. So instead of counting the amount of the number of two-digit numbers whose digits sum to a number divisible by 3, I'm just going to count the multiples of 3. So the lowest one is going to be 21, and then the highest one is still going to be 99. And these are all the numbers that I want to count, and hopefully there's going to be 27 of them. Well, 21 is just 3 times 7, and then 99 is going to be 3 times 33. And so up here in this kind of second list, I was counting the numbers 21, 24, 27, all the way up to 99, and all of those are going to have digits whose sum is divisible by 3. And then if I just divide out the 3, now I just have counting numbers, 7, 8, 9, up to 33, that directly correspond to the list above. So if I count these numbers, I am going to count these numbers as well. And there's a quick trick to count the amount of numbers between A and B. When you kind of list out just the counting numbers, you can just subtract the top from the bottom, but you do have to add 1 to kind of prove my point. If you figure out, or if you want to know how many numbers are in this list, clearly there are 3, but if you do 6 minus 4, you only get 2. So it is really important to add the 1 to actually count the amount of numbers in a list. So to count the amount of numbers between 7 and 33, I'll just do 33 minus 7, add the 1. And the way that I did it in my head right now is I kind of thought of it as 33 minus 6. For some reason, that was easiest for me. And this I can tell is 27. So there's 27 numbers in this list, which means there are 27 numbers in that list. And all 27 of those numbers will have digits that sum to a multiple of 3. Cool. We're all done. Thanks for solving this with me. I'll see you tomorrow. Alrighty.